Hi everyone, and welcome to this lecture on load and resistance factor design, also called LRFD. Today we will be diving into the world of structural design and exploring how LRFD help us to create safe and reliable structures. LRFD is a powerful design method that uses clever math and probability in both the loads of a structure might experience and the strength of the material we use. By considering these uncertainties, LRFD allows us to design with clear level of safety and reliability. This is second philosophy of design, since we studied the main basic design equation that says that the design strength should be greater than or equal to the required strength. What is design strength? It is the product of strength reduction factor into the nominal strength. What is nominal strength? Nominal strength is achieved by formulas given provided by different codes and specifications. What is required strength? Required strength is due to the load effect. The strength produced on a structure is called the required strength. So in every design philosophy we will covering this governing design equation, which says that the design strength should be greater than or equal to the required strength. The threshold is that the design strength should be equal to the required strength. The design strength should not be less than the required strength. This is the main philosophy of load and resistance factor design method, or other two design philosophies that were the allowable stress design method and the plastic design method. LRFD and plastic design method both are same, but in plastic design method we are only using the factor of safety on the load side, not in this side. Only use we will factor of safety on the required strength side. We are amplifying the loads. Now in ASD we use the factor of safety on the design side. We divide the nominal strength by a factor of safety to achieve this governing equation. Now in LRFD we are using the factor of safety in both sides. This is the main difference between other philosophies and this LRFD. In this we will reduce the design strength. We will reduce this design strength, the capacity of a member. We will reduce this and increasing the load effect by a load factor. Means we are amplifying the required strength and reducing the capacity of a member in a building or any structure, due to which this LRFD provides economical and safe members section or any other properties as compared to the other design philosophies. Since you know the basic of LRFD, that are the load and resistance factor design, we will apply the load factor on the load effect side and strength reduction factor on the strength capacity of a member side of a design equation. So due to which we will amplifying the loads and reducing the strength, due to which we will achieve the design equation and the structure might be safe and strong in every terms of serviceability or safety. Factored load. What is factored load? In actual, the loads act on a structure that are called the working load. We will amplify the working load by a factor called load factor, which is also always greater than unity R1. So remember this. So what is actual load? Actual service load. Service load is a load which might be experienced on a structure. So today remember this, the working load is less than the service load. Service load is the maximum load that might be experienced. So remember this. On service load we will amplify the load factor. We multiply the service load by load factor, we will get a factored load. So factored load is a failure load after which the structure might be fail or maybe fail. So remember this. In analysis is the main assumption of LRFD that we are using the elastic range. However, we are also utilizing the inelastic region, the plastic region. We are utilizing the plastic region in ASD we are only utilizing the elastic range. Now in this we are utilizing the plastic range, due to which we get the economical design philosophy. Due to this, it is more economical as compared to the allowable stress design method. It provides less sections, less dimension of a sections. So here this is the design equation, that the resistance means strength reduction factor multiplied by nominal strength, or the resistance factor. It should be greater than or equal to the loads multiplied by the load factor, and then we will sum it. So this is the main design equation. Here remember this, that for every load the load factor would be different. For snow load, for rain load, for roof live load, dead load, live load, the load factor will be different. In next slide we will see the different load combinations, that when the dead load occurs only and bending, then what will be the load factor, we will see in next slide. So this is the main design equation, that the design strength should be greater than or equal to the required strength. Every design philosophy covering this equation. So there are two types of limit state. So the LRFD, also known as ultimate limit state method. So there are two types of limit state. One is ultimate limit state, and the second is serviceability limit state. Ultimate limit state, it considers the strength or turning sliding. It covers the different stability of a building in terms of sliding, overturning, strength, shear, everything it covers. And serviceability, like it considers the crack width, deflection and vibration. It does not allow the member to vibrate after beyond its tolerable limit. So it covers both the serviceability and safety. Remember the one thing in strength reduction factor and load factor, that the strength reduction factor always less than unity, and the load factor might be equal to 1 or greater than unity. This is the last slide of today's lecture, that the different combination of loads uses LRFD, that were the 7 combination. If only dead load occur on a structure, we will use only load factor 1.4, and if the load factor along dead load, live load, and along this the snow load, rain load or roof live load occur, then we will use this combination. In this, remember this, there are we'll use 3 possibilities. If 2 or 3 occur simultaneously, then we will take the maximum value of this 3 factors, loads. Remember this, we will take the maximum value in this combination. In third, there is a wind load, inclusion of wind load, that if wind load occur, then what will be the combination of loads and its factors. So you can see that the wind load occur this, that in steel structure we are not using the wind effect. So here you can take the maximum in this, then by calculating the maximum value we can get in the required strength side of a design equation. So the fourth combination is that in this we will take the maximum value. These are the different dead load representation symbol of live load, roof live load, rain load, earthquake load, wind load. So dead load, you know the dead load that are constant in magnitude. Live load, roof live load due to occupancy, roof live load, snow load, you know different loads, and these are the combination for the load and resistance factor design. So this is the second design philosophy. Hopes you understand and got it. So thanks for watching.